Have you ever looked up at the night sky and seen those tiny, twinkling lights? They seem so calm, so peaceful. But what if I told you that the birth of a star is one of the most violent and chaotic events in the entire universe? Forget peaceful twinkling. Think cosmic explosions, supersonic jets, and gravitational battles on an unimaginable scale. Today, we're pulling back the cosmic curtain and venturing deep inside a stellar nursery. A place where gas and dust churn in a violent dance to create new suns. This isn't just a story of creation. It's a story of survival, destruction, and spectacular beauty. Get ready, because we're about to witness the fiery, chaotic birth of stars. So, what exactly is a stellar nursery? Imagine a cloud. Not the fluffy white ones you see on a summer day, but a colossal interstellar cloud of gas and dust, stretching for light years across space. These are called giant molecular clouds, and they're incredibly cold, just a few degrees above absolute zero. They're mostly made of hydrogen and helium, the basic building blocks of the universe, with a sprinkle of dust grains. To the naked eye, these clouds would look like dark patches in the sky, obscuring the stars behind them. But with infrared telescopes, we can peer through the dust and see the glowing embers of creation hidden within. These clouds are the wombs of the galaxy, the places where gravity begins its slow, relentless work. But these clouds aren't just sitting there peacefully. They're turbulent, swirling masses, shockwaves from distant supernova explosions, the gravitational pull of passing stars, or even collisions between the clouds themselves can send ripples through them. These disturbances are the trigger. They cause parts of the cloud to become denser than others. And where there's more mass, there's more gravity. This is the tipping point. Gravity starts to pull matter inward, creating a dense, spinning core of gas and dust. This is the very first stage, the birth of a protostar. It's like a cosmic snowball rolling downhill, gathering more and more material, getting bigger and bigger. As this protostar core collapses, something incredible happens. The pressure and temperature at its center begin to skyrocket. Think about squeezing a balloon. The air inside gets compressed and heats up. Now, imagine that on a cosmic scale, with a mass millions of times that of Earth. The core gets hotter and hotter, reaching millions of degrees Celsius. While it's not a true star, yet it has unstarted nuclear fusion. It begins to glow brightly in infrared light, a hidden gem inside its dusty cocoon. It's like an oven that's preheating, getting ready for the main event. Around this glowing core, a flat, spinning disk of gas and dust forms, called a protoplanetary disk. This is the leftover material from the collapse, and it's from this very disk that future planets will be born. Now, this is where things get really violent. The young protostar is a messy eater. It's furiously pulling in gas and dust from the surrounding disk, but it can't consume everything. A lot of this material gets superheated and funneled toward the protostar's magnetic poles. And then, bam! The protostar unleashes powerful jets of gas, blasting out into space in opposite directions, at speeds of hundreds of kilometers per second. These are called bipolar outflows. or Herbicaro objects. They are like cosmic laser beams, carving huge cavities through the parent molecular cloud and slamming into the surrounding gas, creating spectacular, glowing shock waves. These jets are so powerful they can stretch for light years. It's the star's way of shedding excess energy and momentum, a violent tantrum that shapes its entire neighborhood. Imagine dozens or even hundreds of these protostars all forming at the same time within the same stellar nursery. It's a chaotic, cosmic battlefield. You have competing gravitational forces, with each protostar trying to pull in as much material as it can. Sometimes they get too close. They can get tangled in complex gravitational dances, orbiting each other to form binary or multiple star systems. Or, in a more dramatic scenario, one might get ejected entirely, flung out of the nursery to wander the galaxy as a lonely orphan star. It's survival of the fittest on a celestial scale. The most massive protostars grow the fastest and have the strongest gravity, stealing gas from their smaller siblings and starving them out. And these massive stars are the true bullies of the stellar nursery. They are the blue giants, the O-type and B-type stars. They are incredibly hot and luminous, burning through their fuel at a ferocious rate. Once their cores become hot and dense enough to ignite nuclear fusion, the moment they truly become stars, they unleash a torrent of high-energy, ultraviolet radiation. This intense radiation acts like a cosmic sandblaster. It ionizes the surrounding gas, causing it to glow in brilliant shades of red and pink, creating what we call an H2 region, or an emission nebula. The famous Orion Nebula is a perfect example of this. You're literally seeing the gas being cooked and lit up by the newborn giants within it. But the violence doesn't stop there. This intense radiation and the powerful stellar winds blowing from these massive stars effectively destroy the nursery that gave them birth. They carve out huge bubbles and pillars in the molecular cloud. The iconic pillars of creation imaged by the Hubble Space Telescope are a stunning example of this process. They are dense columns of gas and dust that are being eroded away by the fierce radiation from a nearby cluster of massive young stars. But within the tips of these pillars, the gas is dense enough to shield itself and continue collapsing to form new, smaller stars. It's a beautiful, destructive cycle where the birth of one generation of stars triggers the birth of the next, while simultaneously blowing away their natal cloud. Eventually, after a few million years, the process winds down. The massive stars will have either blown away all the remaining gas and dust, or gone supernova in a final, cataclysmic explosion that enriches the galaxy with heavy elements. The less massive stars, like our own Sun, will have settled down, their protoplanetary disks slowly clumping together to form planets, asteroids, and comets. The once dark molecular cloud is gone, replaced by a sparkling open cluster of young stars, all born from the same cosmic womb, now drifting apart through the galaxy. The chaos has subsided, leaving behind a family of new solar systems. So, the next time you look at a star, remember its violent past. Remember the cold, dark cloud, the gravitational collapse, the supersonic jets, the fierce radiation, and the battle for survival. The serene beauty of the night sky is born from an unimaginable cosmic firestorm. The universe isn't just a quiet, empty space. It's a dynamic, creative, and often violent place, constantly building new worlds from the ashes of the old. The birth of a star is a testament to the powerful forces that shape our cosmos, a spectacular light show that has been playing out for billions of years. Thanks for joining us on this journey into the heart of a stellar nursery. It's a reminder that even in the most chaotic environments, the most beautiful things can be created. If you found this cosmic story as amazing as I do, make sure to hit that like button and subscribe for more deep dives into the wonders of our universe. Let me know in the comments what cosmic mystery you'd like us to explore next. Until then, keep looking up.